So the sum here is express the following matrices as sum of symmetric and skew symmetric matrix. Okay. Let me write the question. Express, problem is express the following matrices as a sum of a symmetric and skew symmetric matrices. Okay, so the first question here is this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You have to express this matrix as a sum of symmetric and skew symmetric. Another matrix here is 2 by 2 matrix, 2, 4, 3, 2. Okay. Solution. You start by saying, with solving 1. You start by saying let A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now what you do is you take the transpose of A. Therefore, A transpose 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So therefore, skew symmetric matrix, symmetric matrix. Therefore, symmetric matrix see in the theorem, what do you have? In the theorem, what have I written? A is equal to sum of this. This is a symmetric matrix, and this is a skew symmetric matrix. Okay. So we are going to find out half of A plus A transpose. Symmetric matrix is equal to half of A plus A transpose. So let's see, half of say A plus A transpose. Okay. So now find out this symmetric matrix. Half of, add up these two matrices. This is 1 plus 1, 2, 2 plus 4, 6, 3 plus 7 is 10, 4 plus 2 is 6, 5 plus 5 is 10, 8 plus 6 is 14, 7 plus 3, 10, 8 plus 6, 15, 9 plus 9, 18. So half of this matrix. You don't need the bracket here. Okay, half of this matrix. So therefore, if you multiply half with all the elements of the matrix, you get 1, 3, 5, 3, 5, 7, 5. This is 14, not 15. 8 plus 6 is 14. Okay, so this is 7 and this is 9. So half of A plus A transpose, we have got the symmetric matrix. Now we'll find out the skew symmetric matrix.
Yes.
Is equal to half A minus A transpose. which is half A minus A transpose. A transpose is 1, 4, 7, 2, 5, 8, 3, 6, 9. Mr. Govinda, you can hear me? Half of 1 minus 1 is 0, 2 minus 4 is minus 2, 3 minus 7 is minus 4, 4 minus 2 is 2, 5 minus 5 is 0, 6 minus 8 is minus 2, 7 minus 3 is 4, 8 minus 6 is 2, 9 minus 9 is 0. Now if you multiply half with all the elements, you get 0, minus 1, minus 2, 1, 0, minus 1, you get 2, 1, 0. So you've got the skew symmetric matrix. So therefore, according to this theorem, therefore the matrix A, what is the matrix A given? This matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This matrix has been expressed as a sum of the symmetric matrix. Let's see what the symmetric matrix is. The symmetric matrix here is 1, 3, 5, 1, 3, 5, 3, 5, 7, 5, 7, 9. Okay. Symmetric matrix, this plus the skew symmetric matrix. 0, minus 1, minus 2, 1, 0, minus 1, 2, 1, 0. Okay. That is, the matrix A has been expressed as matrix B plus C, where B is equal to half of A plus A transpose is a symmetric matrix, and C is equal to half of A minus A transpose is a skew symmetric matrix. Clear?
Yes,
You
sir.
can check. You can check this matrix is a symmetric matrix. Change the rows to columns, you will get a symmetric matrix. You can check this is a skew symmetric matrix. Change the rows to columns and take minus out, you will get A transpose is equal to minus A. I mean, whatever C, if you take this matrix as C, with this matrix you can check. If this matrix you call B, you can check that B transpose is equal to B for this matrix. For this matrix, you can, if you take this matrix as C, you can check C transpose is equal to minus C for this. Understood? So that is how you do how do you express any matrix as a sum of symmetric and skew symmetric matrix. Let us see the 2 by 2 matrix. This is easier. So let A is equal to 2, 4, 3, 2. The second sum that I gave you. Therefore, you first find out A transpose. A transpose is convert the rows to columns. Okay. So you've got the transpose matrix. So therefore, what is the symmetric matrix? Mr. Govinda, what is the symmetric matrix?
Yes, sir.
Half A plus A transpose.
Yes, sir. Hello.
2, 4, 3, 2 plus 2, 3, 4, 2, which is half of 2 plus 2 is 4, 4 plus 3 is 7, and 4 plus 3 is 7, 2 plus 2 is 4. So this is half of 4, multiply half with all, 2, 7 by 2, 7 by 2, 2. Okay. So this is your symmetric matrix. Now we'll find out the skew symmetric matrix. Half A minus A transpose. Half A minus A transpose. Okay. So now take half of, subtract these two matrices. 2 minus 2 is 0. 4 minus 3 is 1. 3 minus 4 is minus 1. And 2 minus 2 is 0. This we get 0, half, minus half, 0. So therefore, this matrix, therefore, the given matrix A, 2, 4, 3, 2 can be expressed as a sum of this symmetric matrix 2, 7 by 2, 7 by 2, 2 plus 0, half, minus half, 0. Okay. So that is the matrix A has been expressed as sum of two matrices B and C, where B is half of A plus A transpose is a symmetric matrix, and C equal to half A minus A transpose is a skew symmetric matrix. Okay. Now, if you are not sure whether your answer is correct, check. Take this matrix as B, take the transpose of this matrix, and check whether B transpose is equal to B. Take this matrix as C, take the transpose, check whether C transpose is minus C. If this works, then you have made no algebraic mistake here. Is that absolutely clear? This is a very, very important sum. Okay, expressing a particular matrix as a sum of symmetric and skew symmetric matrix and the transpose of a matrix. Okay, so let's see if there are any exercises here in between. See this sum, you can go through. What you do is, see, you go through the examples. Okay, instead of doing the problems, some ISC problems I will solve. You go through some of the examples here. Okay, you go through this one. I told you, no, they will give if A is equal to this and B is equal to this, verify that AB transpose is equal to B transpose A transpose. This is your ISC problem. Go through this problem, practice it. Okay.
Yes, sir.
Go through this problem also, number 52.
Okay, sir.
Practice it with your own hand.
Okay, sir.
Okay, now the exercise problems. In the exercise problems, go through, do this problem. Number 8, verify that A plus B transpose is equal to, sometimes transpose is also written as A dashed, okay? Whether you write A dashed or A transpose, it's the same.
Okay, sir.
So A plus B dashed they have written, so you can verify this, okay? And this number 10 also, verify that A square transpose is equal to A transpose square. Okay, can you do this problem, or should I show you?
Sir, we will do it. We will do it. Do it.
Find out A square, take the transpose. Okay, you will get a matrix. Next, you take the matrix A, take the transpose of the matrix, then square the matrix. Okay, and show that they are equal. Finished.
Okay. Yes, sir.
Let us see symmetric and skew symmetric matrices. There's an exercise on symmetric and skew symmetric matrices. Yes, you go through this. Okay, number 55. If A is equal to this, show that A plus A transpose is a
Okay, sir.
symmetric matrix. A minus A transpose is a skew symmetric matrix. Go through this. Okay. Yes, this type of sum I have done already. Express A as a symmetric and skew symmetric matrix. Right? Do it on your own. Okay. See the example. I'm giving a solved example so that when you if you make
Okay, sir.
any mistake in your multiplication, you can check your mistake. Okay.
Okay, sir. Okay,
If
sir.
A is a symmetric matrix, prove that Ka is a symmetric matrix where K is a constant. Okay, no, this is all proof. So you don't need to do this. Prove that the sum of two skew matrices is also skew. No, not required. Maybe two sums I can do here. Okay, two sums I will be able to do, I think. This you can do. I think you should try one here also. Um, this one, number 7. Find the symmetric and skew symmetric parts of the matrix. Okay. So you need to find half A plus A transpose and half A minus A transpose. Okay. There's not much here. Okay. If you can understand that how to express this matrix as symmetric and skew symmetric, you can do it. But the problem is that
Okay.
they have good problem. They have taken all 3 by 3 matrices, 2 by 2 matrices, sorry, for the good problems. I wanted a 3 by 3 matrix. I think there's nothing to be worked out. Okay. We now just cover adjoint and inverse of a matrix. Very important definition. Okay. First of all, here we define a singular matrix, singular and non-singular matrices. Singular and non-singular matrices. Okay. This time will end, so you will join again. Okay. I'll just take 15 more minutes. I want to finish this,
Okay.
the concept of inverse. Singular and non-singular matrices. If A be a given matrix, such that given square matrix such that the determinant of A is not equal to 0. Remember, determinant of A, not A is not equal to theta, not A not equal to theta. Okay. A be any matrix such that determinant of A is not equal to 0, then A is called a non-singular matrix. Okay. If A be a given square matrix such that det A is equal to 0. You find out the determinant of the matrix A and you find that the value of determinant is 0. Then we say then A is called a singular matrix. Okay. If A be If the determinant of A is 0, then we call it a singular matrix. Remember this definition, singular and non-singular.
Yes,
So
sir.
determinant A is equal to 0 means singular. Determinant A not equal to 0 means non-singular. Okay. Next, what we define here is called the adjoint
So the
or
string is not
adjugate.
coming.
What?